Hi students, today we'll go for another important concept in atomic structure, that is nothing but de Broglie's theory. See, according to this, the minute particles like electrons, where their masses are negligible. So, in case of such type of microscopic particles, if you observe the wavelength of any material particles like electrons, that is inversely proportional to its momentum. This is the statement given by de Broglie. That is based on that dual nature of electron. That means, according to his assumption, electron is having both particle and wave nature. So as per that, the wavelength of that material particle is inversely proportional to its momentum. So that means we can write like 1 by mv also, where m is mass of the electron and v is its velocity. And therefore, as per this, wavelength equal to h by mv. So this is what we call as de Broglie's equation, where h is Planck's constant, and already we observed the value of that Planck's constant in previous discussions. So anyhow, this is the formula what we have to use at the questions related to de Broglie's theory, and directly they will give the mass and velocity, or sometimes they will give the momentum directly. So as per that, we have to use this relation. So according to this, in general, lambda 1 by lambda 2 means, if you are going to compare the wavelengths of the two particles, it will becomes, that is P2 by P1, or that will be equal to M2V2 by M1V1. So this is one direct formula for that calculations. And now here we are going to consider this concept for electron. So for an electron, what are the different relations that we require? So for that, just remember this formula. There is lambda equal to h by mv. Now we will go for electron. See, as far as electron concerned, since lambda equal to h by mv, so in terms of kinetic energies, so now we are considering for electron. So generally here wavelength, sometimes they will give the kinetic energy of the particle. Now we are comparing that wavelength for electron, which is nothing but h by square root of 2m into kinetic energy, where m is the mass of the particle. Now, if you substitute the constant values, that is h2 and mass of the particle, so we will get a direct relation. We will come to that later. But here, since kinetic energy equal to E into V, means electronic charge into V. Here V is accelerating potential. So here E is accelerating potential. So according to this, lambda equal to h by square root of 2m into EV. So like this, here we are having two formulas in terms of kinetic energy and in terms of potential, means accelerating potential. So as per this, if you observe the two relations, that means with two different kinetic energies, so lambda is proportional to 1 by root Ke for an electron, and here it is kinetic energy of the electron. So therefore here lambda 1 by lambda 2 equal to root Ke2 by Ke1. Means if they mention different kinetic energies for the electron, then we have to go for that. And as per this formula, since here wavelength is proportional to 1 by root V, means accelerating potential. So therefore, lambda 1 by lambda 2 equal to square root of V2 by V1. So if an electron was accelerated with different potentials, then this is the way how to find out the wavelength of the electron. And if electron is having different kinetic energies, this is the formula where we have to follow to find out their wavelengths. And now, as far as this electron concerned, see, every time no need to substitute H value or M value. So for that purpose, the direct formula what I am going to give in terms of potentials. So here, if they have given the accelerating potential of the electron, then how to find out its wavelength? On simplification, it is nothing but 12.27 by root of V, means accelerating potential, especially in angstroms. So this is the wavelength of the electron at a given potential. And similarly, suppose if they mention kinetic energy, as per that, wavelength of the electron, that is nothing but 4.9 into 10 power minus 90 by root Ke. Especially here we are going to get in meters. So just remember these two formulas. With respect to accelerating potential in angstrom, this is the formula. After that, we have to convert into centimeters or meters. And kinetic energy, if it is in joules, especially in SI units, wavelength, it should be in meters. So that is around 4.9 into 10 power minus 90. So this is regarding the wavelength of the electron. And now, especially since electron is moving in circular orbit, see here, as like the concept given by Bohr, that is angular momentum, here in this circular orbit, if electron is revolving like a wave, so it should be in the same phase like this. Then only its energy is going to be constant. So for a stationary orbit, here there is one relation, that is nothing but in any stationary orbit, the circumference of the circular orbit is an integral multiple of wavelength of the electron. Means for this 2 pi r, it should be equal to n lambda, where n is number of the orbit. So this formula is another important one, 2 pi r equal to n lambda. Now, as per this wavelength in that circular orbit, there is nothing but 2 pi r by n. But here, if you expand this formula, 2 pi into 0.529 into n square by n. So, nn is especially in angstroms. So, after that, if you simplify all those values, 3.32, of course, in radius, we are going to get z also in the denominator. So now 3.32 into n by z angstroms. This is one direct formula to find out the wavelength of the electron in an orbit of either hydrogen or helium or whatever it may be. So by using this we can find out. So according to this, here lambda 1 by lambda 2 equal to n1 by z1 into z2 by n2. It is another most important formula to remember. Means to compare the wavelengths. So this is another concept related to that. Suppose if 2 pi r is not equal to n lambda, electron is not going to be in the same phase, means then its energy will be changes. That indicates those orbits are not stationary orbit. But since all are stationary orbit, that condition is going to be satisfied. As per that, finally, here wavelength of the electron in the given orbit, that is nothing but 3.32 into n by z angstroms. Okay, so this is one formula. And next one, number of waves. How many waves are made by that electron in that circular orbit in one revolution? So for that purpose, if you want to identify the number of waves in one revolution or rotation, number of waves in one rotation, especially all these are for electron. See, suppose wavelength is lambda, circumference is 2 pi r. So how many waves will be there? 2 pi r by lambda. So that means here the formula is 2 pi r by lambda. But lambda equal to 2 pi r by n. So it will be equal to 2 pi r by 2 pi r by n into n. So it is going to be cancelled. So that will be equal to n. That means in any orbit, the number of waves made by an electron in one rotation, that will be equal to its n value. Suppose first orbit, only one wave in one rotation. Second orbit, 2 waves. Third orbit, 3 waves. So like that, here we have to find out the number of waves made by the electron. So like this, here we have to use this concept for electron. Suppose, of course, here this concept is not going to be stressed in NEET, but apart from this electron, like proton or alpha particle or sometimes neutron, if you want to find out the wavelength, so as separate concept I am giving, that means here as the note, see, if they are giving accelerating potential, then wavelength of the proton, that is nothing but 0.286 by root V, means V is the accelerating potential, especially in angstroms. And similarly, wavelength of the alpha particle, if it is going to accelerate by potential V, that is 0.101 by root V. And now, if you observe wavelength of the neutron, here potential is not going to be influenced because it is neutral particle. So they used to give its kinetic energy. So as per that, 0.286 by root Ke. So here is accelerating potential and here it is kinetic energy. And now, just we are going to compare wavelength of the electron and wavelength of the proton. I will explain one relation, automatically you will get remaining. So for that, here, since we have the formula, that means lambda equal to h by square root of 2m into kinetic energy. Now, suppose if kinetic energy of the electron that is equal to kinetic energy of the proton, means both are having same kinetic energy. So therefore, wavelength of the electron by wavelength of the proton. Since masses are different and everything is going to be cancelled, so that means here it is nothing but root mass of proton by mass of electron. Now, if you substitute the masses, that means with respect to hydrogen atom, mass of the proton is 1 and the mass of electron is 1 by 1836. So 1 by 1836. So now if you observe the ratio between wavelength of the electron and wavelength of the proton, there we are getting root 1836. That root 1836 is around 43 times. So therefore, wavelength of the electron by wavelength of the proton, that equal to 43:1. This is approximate consideration. So in this way, you have to compare the wavelengths of the different particles. So that is enough regarding the de Broglie's concept as far as objective exams concerned. But one thing you have to remember, even though it is explaining the dual nature of the particles, but it is applicable only for microscopic particles, not macroscopic. Suppose if you observe this duster, for this it is not possible to apply this concept because it is a heavier object. So only for microscopic particles we are going to use this de Broglie's concept. So that is regarding the conceptual analysis of de Broglie's theory as far as objective exams concerned. Okay, thank you. Hi students, today whatever the concepts that we completed in atomic structure, especially Bohr's model, de Broglie or quantum numbers, so we will see some just important models, means how to approach that particular bit while answering. So for that, here if you observe the first one, see here there is one question. That means in the form of diagram I am giving that question. See, this is hydrogen atom and here there is an electron in first orbit. So if you want to remove this electron, how much of energy that we require? Means to remove the electron from first orbit of hydrogen atom, the amount of energy required, especially here we are considering in electron volts. See, if you understand the diagram, already the electron is present in first orbit. First orbit means energy of that electron E1, as you know the formula, minus 13.6 into z square by n square electron volts. As per that, energy of that electron, that is 13.6 electron volts. And already we observed one formula, means see the energy required to remove this electron, that is what we call as ionization energy. So now generally ionization energy is nothing but minus of energy of the electron, especially for hydrogen atom. And now, so thereby minus of energy of electron in first orbit minus 13.6. So it will becomes 13.6 electron volts. So this is the minimum energy required to remove that electron from that first orbit. See here, energy of the electron is minus 13.6 and energy required to remove that is 13.6. So how is it going to be? See, for example, here this is the electron present in that first orbit whose energy is 13.6 electron volts. Since we are removing the energy of this free electron, it will be 0. For any free electron, its energy will be considered as 0 because it is not under the influence of the nucleus. So now, to make it as 0 means if you provide an energy which is equivalent to the energy of that electron. So this is the energy what we are providing. So providing energy is 13.6. This is 13.6. And existing energy is minus 13.6. So minus 13.6 plus 13.6. So the total energy of the electron becomes 0. That is possible for free electron. Means at that instant, definitely we are going to remove that electron from the particular orbit. So this is the way how you have to understand while calculating the energy required to remove that electron from a particular orbit. Okay, so this is one model. And next, another one. See, as far as the radius, see for example, here there is hydrogen atom and it is the first orbit. Let it be R1. This is R1 and it is n equal to 1 and here is z equal to 1. That is for hydrogen atom. whose size is R1. Now, here we have four options. That means one is, that is second orbit of He plus. He plus and N equal to 2. And another one, that is lithium plus 2, where N equal to 2. And lithium plus 2, where N equal to 3. And beryllium plus 3, where N equal to 2. Now the question is, if radius of first orbit of hydrogen atom is R1, among these four, whose size will be equal to that of R1? Once again I am repeating, among the four ions, here second orbit, third orbit and third orbit. Means now we have to verify whether radius of second orbit of He plus equal to R1, or second orbit of lithium plus 2 equal to R1, or third orbit of lithium plus will be equal to R1. So like that, for which of these following one, its radius of that particular orbit will be equal to radius of the first orbit. Now, if you observe the hydrogen, for this, here R1, that is nothing but 0.529 into N square by Z angstroms. So, in case of hydrogen atom, this R1 will becomes 0.529 angstroms. Means N square by Z must be equal to 1. So if N square by Z equal to 1, now R1 is going to be 0.529. Now among the four, for which species N square by Z equal to 1? That we have to verify. Now, if you observe helium, means for this first one, N square by Z. N square means second orbit. So here it is 4 by atomic number 2. It will be 2. So it is not the option. And similarly, here B means N square, that is 4 by 3, means 1.333 like that. It is not the option. And C, N square by Z means 9 by 3. That will be 3, which is not the option. And beryllium plus 2. So here means for D, N square 4 by atomic number 4, that will be equal to 1. So for this ion of second orbit, N square by Z will be equal to 1. So if N square by Z equal to 1, definitely the size will be equal to R1. So thereby here this is the answer. So like that we have to verify. So whenever they are going to compare the radius, just observe that fundamental formula. So in this question, you have to verify for which species what they have given. N square by Z becomes 1. So that is the way how to answer this. Okay. And next, another one. Suppose here, if it is related to the de Broglie, so now the information what they are giving means if wavelength of the electron that is equal to its velocity, means if wavelength of the electron is equal to distance travelled by the electron per second, that is nothing but velocity. So now, what about the proper relations? See, here if wavelength equal to velocity of the electron, as per de Broglie, lambda equal to h by mv. So that means h by m lambda. So as per this, lambda square equal to h by m, or lambda equal to root h by m. So this is one way. Or otherwise, if the options are related to the velocity, as per this, v equal to h by mv, or v square equal to h by m, or v equal to root h by m. So both the relations are correct, and we have to go for which relation is going to be satisfied. So this is one model. And next another one based on the same, but that means de Broglie. Here there is hydrogen molecule and helium atom. So this is H2 molecule and helium atom. Now the question is, if both are moving with the same velocity, means let it be V1 and it is V2. So if V1 equal to V2, then we have to find out the ratio of the wavelengths. So then lambda 1 by lambda 2 is what? So if hydrogen molecule and helium atom, if they are moving with the same velocity, what about their wavelengths? See, already we have one formula, that is lambda 1 by lambda 2 equal to m2 v2 by m1 v1. This is the relation. Now here lambda 1 is for hydrogen and lambda 2 is for helium. So for that, if you substitute lambda 1 by lambda 2 equal to m2, since velocities are same, it is going to be cancelled. So m2 4 units and h2, this is molecule, so this is 2. So ratio is 2:1. So like that we have to verify that. Okay. And next another one related to the, see just here we have to use the formula lambda equal to h by mv. And another one related to the de Broglie. See, here there is an electron in hydrogen atom, and regarding that, for example, this is hydrogen atom. We have the orbits like this. Now, in the radius of first orbit, this is N1. If it is R, now what is the circumference? Here they are asking not circumference, that is wavelength. So, if radius of first orbit of hydrogen R equal to x, then in third orbit, if electron is there, what about its wavelength? Now once again I am repeating, if radius of first orbit of hydrogen atom is x angstroms, then what is the wavelength of the electron if it is in third orbit? So that we have to analyze. See, generally, this is R1 x. Suppose if you observed R3, this is R3, means radius of third orbit. Now, what is the formula for lambda? See, lambda equal to 2 pi r by n, or otherwise here we will consider as 2 pi into 0.529 or 53, that is your choice. Or here, since we are going to, instead of in this way, just 2 pi r equal to lambda equal to 2 pi r by n. So as per that, if you know the circumference of circular orbit and its value n, automatically here we are going to get a general expression for wavelength. So as per this, R3 we have to find out. So R1 by R3, that is equal to N1 square by N3 square. So what is R1? X. So x by R3 equal to N1 square, 1 by 9. So therefore R3 equal to 9x angstroms. That is R3. So now here we have to go for lambda 3. Means as per this formula, lambda 3 equal to 2 pi R3 by N3. So therefore lambda 3 equal to 2 pi R3 by N3. That is nothing but 2 pi into 9x by 3. So this is 3. So total 6 by x angstroms. So like that here we have to analyze that wavelength of the electron. So in this very simple, they are giving R1, go for R3, and after that substitute in that formula, that is lambda equal to 2 by R by L. So this is another model. Okay. And next, related to the quantum numbers, if you observe, now here they have given 4 sets. That means for first electron n equal to 4, or let it be n equal to 4 and L equal to 1, and the second one n equal to 4 and L equal to 0, and third one n equal to 3 and L equal to 2, and the fourth one n equal to 3 and L equal to 1. So these are the 4 electrons. Now the question is, you have to arrange in the increasing order of the energy. Means with the help of quantum numbers we have to identify those energies. Of course here, as per our rule, energy of the electron, it depends upon principal quantum number and azimuthal quantum number, except in hydrogen. In hydrogen atom, energy depends upon only principal quantum number. So now first we have to go for n plus L value. So if n plus L value is maximum, energy is maximum. For 2 electrons, if n plus L value is same, then we have to go for n value. Now, if you observe A, for this n plus L value, 4 plus 1, 5. And for this n plus L value, 4 plus 0 means 4. And for this n plus L value, 3 plus 2, 5. And for this n plus L value, 3 plus 1, 4. So now we are going to arrange in the increasing order of their energies. Increased order means first we have to see the least n plus L value. 2 are there. B and D, their n plus L value is 4. That too they are same. Since both n plus L values are same, then go for n value. Here n is minimum. So here energy of D is less than B. After that, A and C both are having 5. But here n equal to 3. So C is less than A. So like that, by using the concept of n plus L value and n value, we have to arrange the electrons in the increasing order of the energy. So this is one model on quantum numbers. And the next another one, correct set, means how to identify whether the given set of quantum numbers that is correct or not. So for that, see n, L and m. Just we are considering up to m. So now first electron, it's n equal to 2, and here it is 0, and it is 0, 3, 2 and minus 1, 4, 2 and minus 3, and 2, 0, already I have given 2, 1 and 0. So like that, there are 4 electrons. This is one electron, second, third and fourth. Now, among these 4, which set of quantum numbers is correct? Here, you have to recollect 3 important points. Means, n should not be 0. And another condition, n and L, they are not at all equal. And if you observe m value, it must be between minus L to plus L only. So by having those points, so for that, first to verify is there any 0 for n? No. So regarding n, all are correct. Next come to L. L should be always less than n. See, n equal to 2, L equal to 0, acceptable. 2, 3, acceptable. 4, 2, acceptable. 2, 1, acceptable. These are also correct. And then come to m. M should be between minus L to plus L. 0, 0, correct. 2, minus 2 to plus 2. In that we get minus 1. Okay. And 2 minus 2 to plus 2. But here it is minus 3. So this is incorrect. So incorrect set of quantum numbers or wrong set. So like that we have to verify whether the given set is correct or not by using those three relations. That is another problem. And next one, see, here there is an electron whose maximum value. For this electron, maximum value of m, let it be minus 3. Maximum m value is minus 3. So then, what about its n value? If it is like that, therefore, the value of n will be. Now see this. Maximum m value, if it is minus 3, definitely the value of L, which is nothing but 3 as maximum. Maximum. Because m should be minus L to plus L. If maximum L value is 3, then what about maximum L value? It is nothing but n minus 1. So therefore, n equal to 4. So this 3 equal to n minus 1. So then n will be equal to 4. Means that electron is present in 4th orbit. So in this way, here we are going to analyze the different models. So these are all as the trial bits I am giving. So try to understand the concepts and try to understand how to approach towards that particular bit. So just as per the concepts we covered in limited way, because as the trial class I am not able to give all the models, just for your understanding purpose and to get an idea how to approach towards the bit, I tried with some examples. Try to utilize this. Thank you.